Hi everybody, Mr. Tannen here making a quick video to go over some of these trig identities. So, we'll start here with number one. We have here cotangent squared over cosine squared. What I think I'll do first is rather than divide by cosine squared, let's try multiplying by the reciprocal. Okay. Just rewrite the rest out. I know I'm not really sure what to do. Oh, but wait, I do know that cotangent squared x is equal to cos squared x over sine squared x, or the reciprocal of tangent. Oh wow, this is quite nice because look at this. The cos squared x's cancel out, and I get 1 plus cotangent squared x. So now if I rewrite it down here, I just get 1 over sine squared x equals 1 plus cotangent squared x. This could actually be rewritten as cosecant squared x. And now that I get here, I feel like this may be one of my fundamental, not fundamental, but Pythagorean identities. So if I rewrite this here, I remember now, if I were to divide everything by sine squared x, what I end up with is 1 plus cotangent squared x equals cosecant squared x. So I could just write here Pythagorean identity because that's precisely this, just from the other way around. Or if you like, you could go through the process and maybe just write it like this. We know this equals cosecant squared x, so we could also say those equal that if you don't remember the name of the identity. Okay, maybe we'll jump down to one that was a little bit spicier. How about number 5? This one looks kind of wild. So, let me think about this. Oh wait, cos squared x and secant squared x. Well, cos squared x, isn't secant squared x 1 over cos squared x? So these actually cancel out and just give you 1. So we just end up with tan x on the left side equals cosecant squared x minus cotangent squared x all over cotangent x. If I go back up here actually and take I'll rewrite it, sine squared x plus cos squared x equals 1. This actually, every time I see a trig function squared and another one, it makes me think of an identity. So, if I were to divide everything by, in this case, actually it's the same one I had above. Cosecant squared x equals 1 plus cotangent squared x. If I were to rearrange this and subtract the cotangent squared over, if I subtract that over, I end up with just the fact that 1 equals cosecant squared x minus cotangent squared x. And so what that means is that this whole numerator just equals 1. So does tan x equal 1 over cotangent x? I'm pretty sure that's one of my fundamental identities, that tan of x is the reciprocal. Well, the reciprocal of cotangent is tan. So I verified the identity there. I don't think we'll see as many like these on the exam, the double angle identities. However, I would focus on knowing the Pythagorean identities and the fundamental identities. Have a great day.